on, I will share with you.
Okay.
Okay. So yeah, Bismillahirrahmanirrahim. So here, can you see my screen?
Yes, that is clear.
Yes,
Yes.
okay.
Okay. So here we have the course outline for our course, and so prerequisite, because you already registered this course. So here we have the distribution of marks, and so here we can see that there are 15 marks for the quizzes and 20 marks for projects. So we will have more than one project, and 5 marks for your attendance and performance, in 25 marks midterm, and 35 marks final exam. Okay. So, and then we will have some quizzes in between. So your main textbook that you will get from the bookstore is this: Fluid Mechanics and Thermodynamics of Turbomachinery by S.L. Dixon and C.A. Hall. And this is 7th edition, so you will get it from the bookstore. When you are going to get books from bookstore?
Next week, doctor.
Fine. And you can search the soft copy on the net also, you can find it. And this is another book, so, and this we will use as a supplement material, like for more practice of examples like that. And this is Principle of Turbomachinery by Seppo A. Corpella. This is Wiley publication. So this we will use for solving some problem from this book also, some examples especially. Okay. So these are the course and learning objectives. So if you see here, so we will be going through different machinery. So first of all, we are demonstrating the principles, and then some difference between the total to total and total to static efficiency. So there are some new terms that you will see. And then the concept of waste energy, utilizing factor, maximization of utilization factor, etc. And then we will do the dimension analysis and similitude. And then we will start the real turbomachinery problems. Like first we will do the steam turbines and its classification. And then we have the axial turbines. And then we have the centrifugal pumps and other centrifugal machines. And then we have centrifugal compressor also. Hydraulic machines means hydraulic turbine. And then we have wind turbine. So in this way, we will cover almost like 4 or 5 major machines that we use basically in the industry. So in these machines, we will see the working principles as well as we will solve some problems. And the project, we will do the simulation and design project, that we are going to model any fluid machine. So we will simulate it, and that project may require like your skills in geometrical modeling like CAD modeling. And then we will use some simulation software that can be SolidWorks, and that can be ANSYS, and that can be COMSOL, to model the uh, any machine. Like it may be a pump, it may be a turbine, to model it, basically to see that how it works and how the fluid is moving inside the machine, and what are the conditions, and what is the performance in your modeling. So these things we will see through our projects. Okay, so moving forward, then so we will do the blended teaching, like some lectures I will record and I will upload directly on the Moodle. And while solving the problem, then some problems I can solve and record and send it to you through Moodle. And other we will solve during our meeting. So mostly when it comes to the problems, then we will do it in our online meetings. And when it comes to the theoretical part, that I can record and upload on the Moodle, so you can download from there. So the meeting will be uh, like every Sunday and every Tuesday. It may not be 2 hour, it may be just like 1 hour, or whatever we required, like depending upon the problem we are solving. Okay. So, and then I have already sent you the WhatsApp group link. So that we can use like for instant messages. And but remember like that, don't expect me to respond your message after 6 p.m. If you send the message after 6 p.m., then it just depends upon like if I'm free from my family and pick up the mobile, I may respond. Otherwise, I will respond it on the next day if you send the message after 6 p.m. So if you are sending it like from morning to 6 p.m., 6 until 6 p.m., then I will respond you on the same day. Otherwise, I will respond it on the next day. You can communicate through email also. So these are our two main channel. Either you can communicate through email or you can communicate through WhatsApp. So here we have the different sections that we will cover from each chapter. Like chapter 1, we will cover this section, and and these are the problems, some suggested problems. You can see, where is my cursor? Can you see that?
Yes, Doctor. Can see it.
Okay. Yeah, good. So there are some problems from the main textbook, and there is some examples from the other textbook. As I said, that other textbook we will use for problems. So in chapter 1, there are some sections and some suggested problems. So you can see in this course outline. And similarly, you can see from the chapter 2, chapter 3, 4, 5, 7, 9, and 10. So these are the chapters that we will cover. So in week 2, we will start the simulation and modeling project. And that is your term long project, basically semester long project. So in this project, usually we decide that we want to model a full machine. For example, like if it is a centrifugal pump. So we will start from the scratch, that we will draw a CAD model and we will do some meshing, and then we will do the flow simulation. Remember that here we are doing the flow simulation because this course is related to the flow simulation. This is not related to the structural simulation. This is not related to structural simulation. So it's related to the flow simulation. And so when we are modeling it, we will not do the structural analysis. We will not do the strength of the structure analysis. We will do the flow analysis, so that the fluid is moving and how is it moving after striking the blade, where is it going, what is the where it is turning, and how much power it is producing, and how much force and impact it is exerting on the machine, and what is the velocity and pressure before entering the machine, and what is at the exit, and how much energy is imparted or gained by the fluid when it is passing through the machine. This kind of analysis we will do. So the next week we will be deciding about the term project. So for term project, so one we will have one term project and we will have two small projects. So the term project will carry more weightage, like 10 or 12 marks, and the small project will carry less weightage, maybe like 3 or 4 marks, uh, one project. So we will have two small projects. So we call it mini projects. So the second week we will start, and we will you can do a mind storming session on the simulation of the machine. You can watch some video. I can share the links of the simulation of turbo machines on the that is available on YouTube. I can share it with you. So why I'm doing this, because this is very important. Like if you see the industry, especially this petroleum industry or any other transport industry where you are transporting the fluid from one station to other station, you need pump. And when you are generating power, then you use turbines. So both of them are very important. So Most of the time, like when you want to see what is the defect and why your performance is less or more, and what is the correct operating condition for any machine, and what will happen if you change the operating condition. So there are two ways: either you can do the experiment or you can do the modeling, and then you can estimate that what is going to happen with the machine if you operate the machine at such and such working condition. So the modeling is important there. Any question?
Uh, Yes, regards to the project, we have to work in groups.
Yeah, you have to work in the group. I will come to that point here.
Uh, okay.
Yeah. So we will have basically three projects. One major project which carry higher marks, as I'm telling to you, like 10 to 12 marks. I will decide it later on. So, but roughly 10 to 12 marks, and the other project will carry like 3 to 4 marks each. So two mini project, maybe 3 4 marks one, and one major project, maybe 12 marks or 13 14 marks, like that. Okay. So these three project activity you will do in groups. So you can make your group of, because we have 20 students, so you can make a group of 2 or 3 students. So we can have like a 5 group. So maximum you can make a group of 4 students. So let's say 3 to 4 students, not more than 4 students in a group. So these three activities you will do in group. Okay. So mini project. So this is the term project. In term project, you will be solving. Let's say you selected the centrifugal pump. So you have to do the CAD modeling of centrifugal pump, and then meshing, and then physical boundary condition setting up of the centrifugal pump, and then some result by changing the operating conditions. Similarly, if you are doing for a, let's say, gas turbine, then you have to do it uh, for that. If you are doing it uh, for uh, for any other engine, uh, or any other turbine. One is the gas turbine, one is the steam turbine, another is the centrifugal pump, and then maybe the axial pump. So there can be four or five variants, and then you have like a 5 groups. So you can choose one machine each group. So whoever is like giving me the proposal first, I will accept it for that group. And then if you want to choose that but you comes later, then it will not be allotted to you. So the the machine will not be repeated. Like if you want to solve a centrifugal pump, then this will be for one group. Okay. So what you can do, you can form a group and you can inform me through email or through WhatsApp that who is your group. Okay. And then there is a schedule for the quiz. The quiz 1 will be in week 3, as you can see here, and then quiz 2 will be in week 2, and so yeah. So here, like this is our quiz 1 in week 3, and then we have a quiz 2 in week 4. So the quiz 1 will be on your chapter 1, and quiz 2 will be on your chapter 2 in week 4. And then we have quiz 3 on chapter 4, and this will be in week 6. And week 7 we will have midterm. So the midterm schedule is fixed, and it is fixed by the department for almost all courses. So it is not going to be changed. So it will remain the same midterm schedule. And then we will offer the mini project. So the mini project, one mini project I will offer in week 3, and the second mini project I will offer after the midterm in week 9. And then we will conduct the quiz 4 and quiz 5. So the quiz 4 in week 10 and quiz 5 in week 13. And then we'll have final exam. So this is the course outline and the schedule for the course delivery. So you can see, like, the week wise we will complete the chapters and complete the course outlines. Okay, so any question until now?
Doctor, are all 5 quizzes graded, or you are selecting best 4 out of 5?
All 5 is graded, but we can decide later on in this thing. It depends upon. So
Okay.
yeah, because what I plan is maybe like I will grade all 5 quizzes, but later on I can take the decision. So like there are 5 quizzes, so 3 marks each. 3 marks each. Yeah.
Right.
Okay. Any further question regarding this? Okay, good. So we can start the first introduction chapter today. And let me know if you can see my slides, right? And if not, let me know.
We can see it
So can you see my
pretty.
slide? Can you see my
Yes.
slide? Okay.
Yes.
Okay,
Yes.
good. Good. So this is the first chapter, is just introduction and nothing more. And we will basically just introduce what is turbo machine and all. Okay. So this is the name of the first, this is the textbook that we will use. And this is the basically the reference book. And we will use this book for some examples. And but both our books are basically about the same topic. And if you are not able to understand any concept from book main text, then you can choose the another text to understand that concept, because sometimes the language of the book, for one topic it is easier to understand, and the other topic it is um, you can find the uh, another book is easier to explain. And these are other texts that can be used as a reference if you want to study in more deeper in the topic. Okay, so what is a turbo machine? So those machines in which the energy is transferred either to or from a continuously flowing fluid. So basically there is a continuously fluid and that enters into the machine, and the interaction may be of two types. Either fluid is transferring energy to the machine or machine is transferring energy to the fluid. So when the machine is transferring energy to the fluid, then it comes in the category of pump. And when the fluid is transferring energy to the machine, then it comes in the category of turbines. And by the dynamic action of the moving blades. So there are moving blades in this machines, right? A rotating blade row, a stator, an impeller changes the stagnation enthalpy of the fluid moving through by doing either positive or negative work. What is the stagnation enthalpy here? Anyone can answer this thing. What is the stagnation enthalpy?
It is the energy of the flow.
Yes, it's energy of the flow. Okay. Enthalpy, interior energy, these are the forms of energy. Yes. So, but what is the enthalpy? You know, what is enthalpy? How do we define enthalpy?
Internal energy plus flow work.
Yes, internal energy and flow work. Very good. So the enthalpy is basically the internal energy and the flow work. So that means when the fluid is in motion, that only it can do the flow work, right? If the fluid is not in motion, that we don't define enthalpy. If the fluid is not in motion, we define the enthalpy when there is a motion of the fluid, and the fluid is doing some work. So the internal energy plus the fluid. So stagnation enthalpy means that if the fluid is moving and somehow, so when the fluid is moving, then it is having two energies, that is the flow energy and the capacity to do the work, that we call it the flow work, and the enthalpy. So the flow work and enthalpy, there are two things. And at that time, the enthalpy, we call it the static enthalpy or simply enthalpy. If we just call it enthalpy, that is static enthalpy. So if somehow in any machine or something, you brought the fluid to the rest, that there is a moving fluid, but you stopped it. So what will happen when you stop it? Then its flow work and that the kinetic energy will be converted into the kinetic energy will be converted into the that will come into the rest, right? So there is a conversion, and that conversion will enhance its internal energy if it brought to the rest. So basically the sum of the two, the kinetic energy and the enthalpy, we call it stagnation enthalpy. So the energy in the motion and the enthalpy together becomes the stagnation enthalpy. So the stagnation enthalpy, so any fluid which is having the stagnation enthalpy, that is the kinetic part and the static enthalpy. And that when it enters into the turbo machine, then the two things can happen, either the positive work or the negative work. Either the fluid do the work to the machine and the machine gives the work outside and output as a work, or the second is that the fluid is taking the work from the machine, so the work is negative. The machine is doing the work on the fluid. Two things can happen, right? So the turbo machine, mainly it can be categorized into two broad categories. One is the power producing machines, other is the power absorbing machines. Power producing machines, mainly examples are, what examples for power producing turbo machines?
Pumps and compressors.
Turbines.
Power producing is turbine. Pumps and compressor, they absorb power, right?
Okay,
Turbines, it can be hydraulic turbine, it can be gas turbine, it can be steam turbine, etc. So the power producing are the turbines. And then you can see that this kind of flow chart you might have seen in your heat engine part. Do you remember it? That the fluid is entering. In the heat engine part, it is the Q which enters into the heat engine. Here it is the fluid. The fluid is entering into the machine in the rotor part, and the rotor is developing the work. And some of the energy the fluid is taking outside. That means not all the energy of the fluid is being utilized by the rotor. Only part of it being utilized, and there we define its efficiency. So the fluid entering into the machine, doing work, and at the exit it has low energy as compared to the inlet part. Power absorbing machine, that at the inlet it has a low energy, at the inlet it has low energy, and then impeller is doing work on the fluid, and the fluid is taking work from the outside, and at the end the fluid has very high energy. That is the case of compressors and pumps, where the impeller works on the fluid and its pressure and velocity increased. Clear, huh? So here are some examples and some schematic that of the machines, like the first one, A. So can you imagine this? These are the blades of the at the hub, and this is a machine which is rotating. Can you imagine that? Anyone? Can you basically visualize these diagrams? Like this is a hub, and then this is a rotating part. So it's rotating, and then the fluid is entering from this part and leaving from this part. Yes, anyone? Let me know.
It is not clear, doctor.
Yes, like you can consider that this is the uh, outer wall, and this is the inner wall of a annulus. Like here, it's like that basically, and it's like that, is it? So the fluid is moving here, and the fluid is moving here, right? And this is the hub, and which is rotating, and this is the axis of rotation.
Yes, doctor. Yes, yes,
Oh.
doctor.
This is, yeah, okay. So now it is clear, right? This is the axis of rotation, and it is rotating. and there are blades mounted on this, and there are blades mounted on the outer surface also. So the fluid is passing through these blades, and the blades, so there may be two types: either blade are doing work on the fluid, or the fluid is doing work on the blades. So the fluid is entering into the blade and leaving out the blade. So it is entering axially and leaving out axially, right? This is another example here. So this is the shaft and it is rotating, and this part, and this is the part which is connected with the shaft and it is also rotating. So the fluid is entering here and then it is leaving out. So there are blades mounted on this shaft, and these blades either takes the energy from the fluid or impart energy to the fluid, and based on that we can define whether it is a part of a turbine or whether it is a part of a pump or compressor. So the fluid is entering, but it is not entering exactly the radial direction, and it is leaving out not exactly the radial direction. So let's say this is radial direction and this is the axial direction, the two directions we have, is it? So the machines can be that the fluid is entering axially and leaving out axially, and the machine can be that the fluid is entering and striking the blade of the machine at a certain angle and leaving out the blade of the machine at a certain angle, right? Is it clear?
Clear, Doctor, clear.
Yeah, clear, Doctor.
Yes.
Okay, good. So how many of you have seen the centrifugal pump when its cover is open? When its cover is open. When its cover is open, then you might have seen that there is a impeller inside the pump. An impeller has certain blades, certain protrusions and certain blades. Anyone have seen it? Nobody? Nobody has seen it?
No.
You see, Doctor, a
Uh,
smaller
uh,
one. It is like a plate.
Yes, it's
A plate
like a plate, and there are blades mounted on the plate.
yes, yes.
Yeah, right. There are blades
It
mounted
is
on the plate.
around plate.
Yes, exactly. So let me check in other slides. I might have this. So like this. Can you see that?
Yes, Doctor.
Yes.
Yes.
Like this. Like so. These are the blades, and the blades are mounted on the shaft, or we call it hub. Okay. So coming back here, that so this is here the fluid is enters at the center axially here. The fluid enters here and then leaps out in like this radially. So these are the different configurations, right? Here the fluid is entering axially, leaving out axially. Here the fluid is entering axially and then striking the blade in the radial direction. So striking the blade in the radial direction and leaving out radially, right? Here the fluid, here this is the shaft, and these are the blades mounted on the shaft. These are the runner blade, and these are the guide vanes. So on the runner blade, when the fluid comes here, it strikes here, right? And then it leaps out in this direction. So if this is the axial direction, because this is the axis of the shaft, and then this is the radial direction, then the fluid is entering radially, but leaving out axially. Leaving out axially, right? And in the blade, it is basically the mixed. It is neither completely radial and nor completely axial from the this runner blade we are talking about. How is it striking at the blade, and how is it leaving out the blade? So striking the blade radially, but leaving out blade is not radial. Here it is entering the radially. Now we are looking at the E part. Here it is entering the radially and striking the blade in the axial direction and leaving out the blade in the axial direction, because this is the blade part. Is it clear?
Clear, Doctor. Yes.
Yes, clear.
Okay. Now this is the ring, and on the ring there are blades, and in the blades here on the runner, and then the fluid is coming from this nozzle, and then this is striking the blade like this, and then blades are moving. So here it is striking tangentially. This is the shaft, and it is rotating, and the fluid is striking the blades tangentially. Right. So in the A part, when the fluid is striking the blade axially, leaving out the axially, then we call it axial flow machine. Axial flow machine. In the B part, when the fluid is striking the blade and it is not purely axial, and it is leaving the blade, it is not purely axial or radial. So it's a mixed between axial and radial. So this we call it mixed flow machine. Mixed flow machine, right? And the C here, the fluid is coming to the shaft and the shaft is rotating, and by the centrifugal action the fluid is going outward radially. So we call it centrifugal machine. It can be centrifugal pump and it can be centrifugal compressor. Now come to the D part. In the D part, the fluid is entering and striking the blade axially, but leaving out of the blade is not axial. As you can see here, it is neither axial and nor radial. So it's a mixed of the two directions. So we call it mixed flow machine. And the name of this kind of machine is given by, this kind of machine is basically developed by the scientist, and his name was Francis. So this turbine is named after him. We call it the Francis turbine. Now come to E part. In this part, the fluid is entering into this, basically we call it the casing, and the fluid is entering into the casing, and from the casing it is turned and is striking the blade axially here. So it's striking the blade axially and leaving out axially from the blade. So this is, we call it axial machine. So our concern is that how the fluid is striking the blade and leaving out the blade. So in both, so it is striking the blade and leaving out the blade is in axial direction. So we call it the axial flow machine. And this machine is developed by the scientist, and his name was Kaplan. So we call it Kaplan turbine. So another type of machine that the fluid is striking the blade tangentially, so we call it tangential flow turbine. Tangential flow turbine, and this is developed by the scientist, and his name was Pelton. So we have seen that there are centrifugal machines. This is centrifugal machine. So in the centrifugal machine, the fluid is entering it axially, but when it comes to the impeller, it strikes radially and leaves out radially. So it's a radial machine. It strikes radially and leaves out radially. So it's a radial flow machine. Here it strikes axially, leaves out axially. It's a axial flow machine. And here it enters not purely axial direction and leaves out not purely axial direction. So it's a mixed flow machine. Right. And this one the fluid is entering axially, striking the blade radially, but leaving out of the blade is neither axial nor radial. So it's again a mixed flow machine. And this is axial flow machine because the fluid is striking the blade axially and leaving out the flow axially. And here it is a tangential flow since the fluid is striking the bucket tangentially. So are these things clear to you?
Yes, Doctor, clear.
Okay, good. Now moving to the
Doctor, is the centrifugal machine,
yes, centrifugal machine.
a
Yes,
centrifugal,
yeah,
how does
centrifugal.
the fluid come in? In which direction?
The fluid is coming out like you might have seen the fans, right? Air fan that we have in
Yeah.
our homes. The fluid comes out towards the blade axially, right?
Yeah.
Right, and leaves
Okay.
the blade axially. So this is axial flow machine. This is
So
axial
the
flow
air
machine.
enters like perpendicular to the
Blade.
axis of. Okay. Yeah.
No,
Right.
perpendicular to the. No, it is parallel to the shaft. Parallel to the shaft. Right. Okay. Your centrifugal question will be clear in this diagram. Can you see this slide here?
Okay.
Can you see this slide
Yes.
here? Yeah. This is your radial machine. And we also call it centrifugal machine because there is a centrifugal action involved in this machine. Right. So what is happening here? If you can see. What is happening here? Here, the fluid is entering axially here, right? The fluid is entering axially. Can you see this?
Yes.
Yes, Doctor.
The fluid is entering axially, but when it strikes the blade, it strikes here. It strikes here and then leaps out radially. Leaps out radially. So the fluid entered here. Now the fluid is here. When the fluid is entered here, until now there is no striking. When the fluid is entered here, until now there is no striking from the to the impeller. It strikes the impeller in the radial direction and leaps out in the radial direction. Is it clear to you? The fluid
Yes.
enters the pump. Fluid enters the pump and it reaches like innermost part of the pump. And until now it has not struck the impeller. And now it strikes the impeller in the radial direction. Now it strikes the impeller in the radial direction. It has reached to the inner part. And now from here, it is striking the impeller in the radial direction and leaving out in the radial direction. So this is, we call it the radial machine. And there is a centrifugal action involved in it. So we also call it centrifugal machines. Is it clear?
It's clear.
Okay. Now in this
Yes.
part,
Thank you.
here the fluid is entering and it is reaching to the innermost part. And here it is striking the blade, but not in the radial direction. It's striking the impeller at a certain angle and leaving out at a certain angle. So there is a centrifugal action involved in this also, isn't it? Because centrifugal, when it moves, the centrifugal action is involved, and it will try to move the fluid outward to this from the center. So centrifugal involved in that centrifugal action, but it is not completely basically throwing out the fluid in the radial direction. It is throwing out the fluid from the impeller at a certain angle from the radial direction and axial direction. So we call it mixed flow machine in this case. Clear?
Clear, Doctor.
Clear. Okay. So let's say that the fluid is coming here. The fluid is coming here, right? And then the impeller is basically throwing out the liquid radially. The fluid is entering here, and then the impeller is throwing out the liquid in this direction. So this is radial flow, and this is mixed flow. And here the fluid is entering the axial direction and leaving out the axial direction. So this is axial flow machine. So in real life, you might have, you will see there are many kind of blade designs, and depending upon that how it strikes the blade and how it leaps out the blade, we can basically classify them into three major categories of these machines. Like either it is axial flow machine, or it is a mixed flow machine, or it is a radial flow machine. So why do we categorize them? Because we want to do the analysis of the forces, how the force is acting on the blade and how the blade is basically exerting force on the fluid. So that becomes easier for us to understand what are the direction of the forces and the momentum. Okay. So for that point of view, this is important. Okay. Any question until now? Okay, now moving forward. So there are some power generating machines, and there are some power consuming machines. So the power consuming machine means pumps, fans, blowers, compressors. So when we deal with incompressible fluid, then it becomes a pump. And when we deal with compressible fluid, then we call it fan, blower, compressor, etc., etc. Right? For the power generating machines, when it is incompressible fluid, then it is mostly hydraulic turbines. Steam is a compressible fluid. So the steam, gas, and wind, these are all basically compressible fluid. So these are uh, comes under compressible fluid. These turbines, gas turbine, steam turbine, wind turbine, etc. Okay, so now for just for general for your general knowledge purpose, like for example, this is for how much is the contribution of the energy production or power production from the nuclear resources, how much is the power production from the fossil fuel resources, how much is from the renewable energy resources, and how much is from the hydraulic resources, like that. So, and this is the, you can see the inside the structure of the steam turbine. So it's highly complicated machines, and not many companies in the world are producing. So there are only few companies which you can basically count them on the fingers, especially like uh, Doosan, Siemens, GE, very high names there which are producing this company, and they are providing these services to these power producing devices. So wherever they are installed, either they are installed in Oman, UAE, or Saudi Arabia, wherever, so they install it, and then even they take the service contract for maintenance also. So this is 100 megawatt. Like, so the steam turbines are usually very high power producing turbines, and the single unit itself can produce 100 megawatt and more. And we know that what are the operating conditions for the steam turbines. For the general operating condition, there are like low power producing steam turbines, and there are high power producing steam turbines. And so this is the limit, and this is basically for the high power producing turbine limit for 100 megawatt power production. So 540 degrees Celsius temperature and 14 megapascal pressure, and the RPM is like 3,500 to 15,000. And this is ultra high power producing plant. So the temperature is very much high, and the pressure is also high, very high, 60 megapascal, which is very high pressure for steam turbine. Sorry. And then this is the critical temperature and critical pressure for a steam turbine. And then we have the gas turbines. Its structure is also very complicated. And so uh, the gas turbines can be very small to can be very large. So like for some places where we need a small power production, we can have a small unit, and when we use large power, we can have large unit. And mostly steam turbines, they run uh, in combination, like you can have the parallel combination or tandem combination, or sometimes the gas turbines can be connected with the steam turbines. So whatever is the steam turbine exhaust gas turbine, because the gas turbine works at a very high temperature, higher than the steam turbines. So whatever is the exhaust of the gas turbines, that can be utilized to generate power for the steam turbines. And these are the hydraulic turbines. So this is basically the Pelton turbine. And you can see what kind of blades is here when the jet strikes like on these blades, and then it moves and then connected with the generator, so the power production takes place. And this is the Kaplan turbine, and you see how big is it. And if you see like from a single unit how much and which machine can produce the most power, then it is a hydraulic turbine from a single unit. And like across the world, and they are installed in a huge size, and they are producing the most of the apart from the nuclear power production, they are producing most of the powers in the world, these hydraulic turbines. And they are basically uh, a renewable form of energy. Like you don't need to because they are run by mostly the water collection at the dams. So it's a form of it's not that like the modern renewable resources is like kind of a uh, water body. So you're not spending any fossil fuel on this. And then we have the wind turbine. And so the wind turbine also very large. Like if you see the wind turbine, the diameter of the basically the blades, it goes up from like starting from very small, like 1 or 2, 3 meter diameters to it goes up to like 30, 40 meter diameter and even more. And this is compressors. And the compressors are mostly, are you with me? I cannot hear anyone. Yeah, you are listening to me, right?
Yes,
Yes,
you are listening.
Director. Yes.
Okay. Okay. So what do you think the usage or the application of compressors? Where do you see the compressor is installed and it is utilized?
The air conditioning, for example.
Air condition. Yeah, air condition. There is a compressor that is reciprocating compressor. Yeah, reciprocating compressor. There is anywhere else?
Also in jets,
Where? Sorry.
planes,
Planes. Yeah,
jet
yeah,
engine.
yeah. Jet engines. They are basically a integrated compressor. They have integrated compressor basically. Yeah, and
In power plants, Doctor?
power plants, gas turbine power plants. They have the compressors as well. And okay, so for like the one compressor and basically the unit that includes the gas turbine and compressor. So the gas turbine is basically equipped with uh, compressor. So here, this is basically the combustion chamber, and then these are the two stages of the gas turbine, and here it is a compressor. It takes the air and then it compresses through different stages, and then it's sent to the combustion chamber, and then it is basically these are the two stages of the gas turbine which develops the power. So the compressors, other application of the compressor, that is the basically they are used for transmission of gases from to longer distance. So the natural gas transmission, like you might have seen that there are transmission lines across the countries, like from Iran, from Qatar, because they are the mostly gas producing nations, and then they transport the gas to different places, like to China, to India, and to Pakistan, and to other European countries, and all that. So some of the countries, they have the direct transportation lines, and other countries, they just basically transport in a container. So in a container, when you are transporting the gas, then because the gas, you need a very large container. So what they do, they first compress it. They first compress it and compress it to very large extent, and it is almost like a solidification stage. So they compress to a very large extent. So for that purpose, they basically use compressors first of all. And the second, when they want to transport from one country to another country, then they need a very high power compression to push the gas from one place to other place, right? So for that purpose, they use high power compressors. These are the pumps and blowers. So this is pump, and this is blower basically, and this is also blower. Yeah. So the pumps and blowers you might have seen at different places, right? There are several in our workshop laboratories also. When you do some experiment, and in your house also, you might have a pump. Any transport line, the municipality transport line, they transport the water at different places. They have centrifugal pumps. And the blowers also, like air conditioning system, they have blowers, and fans we have at our home. So we know that, right? So what is the difference between basically the pump, blower, and fans? That will come in the next chapter. What is the difference? Pumps, blowers, and fans. Okay, I'm leaving it to you. In the next lecture, we can discuss it, right? What is the difference between pump, fan, and blower? Okay, so here we reach to the last slides of this introduction part. He's a scientist, Gustav D. Lebon, and he developed the turbine for producing power, and he was very famous in this field of turbomachinery. And then we have Charles Algernon Parson. He also developed a turbine, and he is also very famous in this field. So this is related to the steam turbines. These are like delay bar. This is also related to the steam turbine, and he's also related to the steam turbines. And these three scientists are related to the hydropower, hydraulic power generation, like the power generation through the big dams, and then you connect the very high power hydraulic turbines to develop power. So he developed the Pelton turbine, he developed the Francis turbine, and he developed the Kaplan turbine. So these are the names of the turbine, hydraulic turbines, basically Pelton turbine, Francis turbine, Kaplan turbine. So these are the we call it like very influential scientist, and they gave the concept of these turbines and prove it. Okay, so here we finish. Any further question, etc.? Hello, hello.
Yes, Doctor. No.
Yes.
Yes. Any further
Yes.
question?
No question, Ibrahim.
No question. Okay.
All clear. All clear.
Okay. Okay. I will just count some names. Murshid.
No question.
Okay. No problem. I will take this snapshot, and then I will count from this snapshot your attendance. So remember that your attendance is a must, and I have assigned like 5% for your attendance as well. So attendance and your participation during the class. Maybe next time what I will do, I will share with you an Excel sheet and on the Google Doc, right? I will share an Excel sheet on the Google Doc while you joining the meeting. at that time you can fill up it, and so that will be counted as your attendance. And I can see basically the username who entered it, and I can also see like what time it entered, so that will clarify that you attended the meeting and you filled up the Excel sheet, right?
Inshallah.
Okay, Doctor.
Okay, so here we finished this chapter, and there are theoretical part, the introduction part basically you completed, and then we start the chapter one, some theoretical concept. So the theoretical concept, as I said, that some of the concept I will record and upload on the Moodle, and if there are some concept, either we can do it through the meeting, and the numerical part also we can do it through the meeting. So thank you very much for attending this meeting, and we will do it every week on 2 days for like 1 hour or whatever time is required, inshallah.
Inshallah.
So if no further question, then we can leave the meeting. Thank you very much, all of you, and all the
Thank
best
you,
for
Doctor.
for this course. And I hope you will enjoy this course because I have made it quite significant. It is project oriented, inshallah.
Inshallah, inshallah. You will
Thank
complete
you,
it.
Doctor.
Inshallah. Thank you, Doctor.
Okay, okay. Thank you very much.